All right, section 10.2, the quadratic formula. Um, this is actually a formula derived from being able to complete the square, but for us, we just want to be able to use it. And it solves any quadratic equation in standard form. So first of all, we notice that this is written in standard form. This is a standard form quadratic equation. And what that means in terms of composition is the left side, you notice ax squared plus bx plus c is basically just expanded. It's an expanded form equal to 0. All right, when we do have this, you notice the coefficients of the x squared term. A represents the coefficient, b is a coefficient on x, and c is a coefficient on or is the constant, I'm sorry. So a, b, the plus b, whatever the b is for the coefficient, and then finally the constant c. So I'm going to color code these. The solutions to this equation then would be x equals, and it's a big fraction, it's the opposite of b, so I'm going to do that in red, plus or minus the square root of b squared minus 4ac. So the last term inside or underneath the square root is negative 4 times a times c, and then that's all over 2 times a. So this is the quadratic formula. Let's try it on this first one down here. Solve 4x squared minus 7x minus 2 equals 0 by using the quadratic formula. So this quadratic is already written in standard form, and we just have to recognize the coefficients. So the coefficient of x squared is 4, that's the a. The coefficient on x is negative 7, that's the b. And then the constant is negative 2, which is my c. So we're just going to take those values and plug it into our formula. So we get x equals, and if you look at the formula, I like to break it up into pieces. First of all, let's drop this down a little bit. We have a big fraction. We have the two terms on top because the plus or minus, and then the square root is the whole second term. All right, so this is kind of the makeup of the formula. So we start with the opposite of b. So b is negative 7. The opposite of b is positive 7. And then underneath the parenthesis, or underneath the square root, is b squared. Well, negative 7 squared would be 49. So this is b squared. The 7 is the opposite of b. And again, I'd rather remember it that way than plugging in negative b plus or minus b squared. And I just like to evaluate those as I plug them in. And then keeping with the formula, the next term underneath the square root is negative 4 times a. So that'd be times 4. And then times c, and c is negative 2. And then the denominator is 2 times a. So again, I always like to use parentheses when I'm plugging in. So there's our quadratic formula. Substituted the values substituted in. So we're going to get used to simplifying this expression. So where should we start evaluating? Well, in the numerator, underneath the square root, we need to figure out this value of those two terms. We have two terms here. 49 is already done, but I need to find this value so I can combine those. So the first thing I'm going to start with is underneath this radical, I got 49 for my first term, and then my second term would be negative 4 times negative 2. So I have two negatives. Negative 4 times negative 2 is 8, times 4 is 32. So this is a positive 32 here. So when I add those together, I get 81. So I'm going to leave everything else. The 81 is I'm going to insert that underneath the square root. And then I'm also going to evaluate the denominator, which is 8. So we'll evaluate underneath that square root and then the denominator. So now we want to take this, and the square root of 81 we can simplify. So that's the next thing we're going to do is simplify this square root. So we're going to get x equals 7 plus or minus 9, right? The square root of 81 is 9, and that's all over 8. So finally, we can break this up because we can evaluate the plus or minus. So one of the answers we get would be x equals 7 plus 9 over 8, which is 16 over 8, which is 2, or x equals 7 minus 9 over 8, which is negative 2 over 8, which is negative 1/4. So our answers end up being x equals 2 or negative 1/4. Now, these answers came out to be integers, actually rational, because we have a fraction there. So by doing that, we also noticed that we could have factored that quadratic. So if we look at the quadratic, we could factor that. So I'll bring it down. So I wrote the original equation down, the 4x squared minus 7x minus 2 equals 0. And we can actually solve this by factoring. So if we, again, try to factor by trial and check, you'll notice that it does factor to 4x and x minus 2 plus 1. And if you check this, it will work, but the factors are 4x plus 1 and x minus 2. So if it factors, then we can just set each factor equal to 0. And then we can solve each of these. So we'll subtract 1 from both sides here, and we get 4x equals negative 1, dividing by 4, canceling the 4 there, we get x equals negative 1/4. Or here, obviously we could just add 2 to both sides, and we get x equals 2. So we get the same answer no matter how we solve it. Factoring in this case depends on your, how well you like the factor, but factoring will solve this quadratic. But the quadratic formula, when we plug it in, gives us the same answers. We just have to simplify that quadratic formula, which sometimes can be a pain. That's why we're going to work on that in the next section. So what happens if the numbers don't come out very nice? And we'll cover that in the next section here.